Welcome to physics lecture series. Our topic is displacement time graph. In this topic we will learn two types of graphs, one without data and one with data. In without data graphs we will learn the motion of the object, either it is moving forward, backward, its velocity is constant or changing, or the object is stationary. To deduce this general information we need to keep one parameter, delta S, change in displacement, or delta T, time interval should be constant. So we keep delta T constant. Let's move to the forward graph A. When delta T is kept constant, when delta S is constant, delta T is constant, so velocity is also constant. The graph B is also a straight line, but its slope is higher. In the same time interval, delta S is same within the graph. So delta S is again constant, delta T is constant, velocity is the same or constant. In graph C, slope is much smaller than A and B. As delta T is constant, so delta S along the both time intervals is also same. The change in delta S is the same, so velocity is also constant. From these graphs we deduce that when slope is higher, the change in displacement is larger, so their velocity is larger. If the slope is smaller, their change in displacement is smaller, so is their velocity is also smaller. In graph D, we have combined two straight lines of different slopes to elaborate the difference in their velocities. So here delta T is again constant, but their corresponding delta S is different. In higher slope, delta S is larger, in smaller slope, delta S is smaller. At higher velocities and lower slopes, the object is moving at smaller velocities. In graph E, there is a straight horizontal line parallel to T axis. As change in displacement is 0, so velocity is 0 and the object is stationary. In graph F, a straight line is going upward and then it is going downward. We deduce the velocity information in this graph. In upward slope, as delta S goes positive, so it means that delta V velocity is also positive. When velocity is positive, it means that an object is moving forward. But when it goes down, its sign delta S goes negative, and so is the velocity goes negative. But as it is straight line, that means that they are moving at constant velocity, but in going backward. So when slope is positive, object is moving forward with constant velocity. If the slope is negative, the object is moving backward with constant velocity. Graph E shows a curved line which demonstrates a non-uniform change in displacement with respect to time t. When S is non-uniform, it generates velocity non-uniform. We can explain it as the object is moving with a non-uniform velocity. Now we have another graph with data points. It is as a straight line, and time interval is taken along x-axis, which is marked, and displacement along y-axis, which are marked from 2, 4, 8, 6, 12. We first take two time intervals, first T1 at 4 seconds and T2 10 seconds, and see their corresponding displacements. At T1, S1 is 6 meter approximately, and at T2 10 seconds, its displacement is 18 meter. According to the formula, velocity is equal to S2 minus S1 over T2 minus T1. That is equal to 18 minus 6 over 10 minus 4, so we get 12 over 6 meter per second. Velocity will be equal to 2 meter per second. From here we calculate the velocity of the moving object at 2 meter per second.